Good morning to all. So today we see about the topic is micrometer analysis or screw gauge analysis. So both are equal, screw gauge or micrometer. So both are equal. So this is the micrometer, screw gauge, and also its main components is head scale and pitch scale. Head scale is the fixed scale. The pitch scale is the rotating scale. Okay, head scale is the fixed scale. Pitch scale is the rotating scale, and also this is a locking screw, and this is a measuring zone. Already I told the vernier caliper, same concept will be applied. Main scale, vernier scale, locking screw, measuring jaws. So same like as measuring jaw, locking screw, you rotate, it means some little bit one sound. That is the indication of the lock of the object, and also the main scale is equal to the head scale and the vernier scale is equal to the pitch scale in micrometers. Okay, but micrometer least count value is the 0.01 mm, but caliper means 0.02 mm. Already I told you least count. What is least count? Least count is the is minimum measurement. So that value is the 0.02 mm for caliper and 0.01 mm for micrometer. Okay, so this is my job. Okay, simply you have to measure the diameter of the job. But in this micrometer, one disadvantage is the maximum value is the 25 mm. But caliper means you have to measure maximum value almost 145 mm. Because both are mentioned in mm only, but concept is the same concept. But accuracy is higher than caliper. Why? Means you see the head scale, the one values, the topper values will be 0, 1, 2, 3 like means, and also the minimum value will be 0.5, 1.5, 2.5. For example, you first starting from 0, the above value is the 0.5, and then below value is the 1, and the above value is the 1.5, and the below value is the 2, so 2.5, 3. So you have to measure very closely, because our close output is very important in our measurement zone. In our measurement zone, the close output is very important, because the accuracy is the close output, precision is the repeated values. Already I saw a lot of measurements. Okay, so the close output is very important in our road. Okay, so simply this is my job. I release the clearly note down, just I log. Okay. Then you can easily remove the workpieces, or you cannot remove, means that is a no problem, but the value will be clearly viewed 15. Clear view will be 15, it's not 15.5, only the 15. So our head scale is the 15 mm. Okay, please note it, head scale will be 15 mm. And then coincidence is very important. The coincidence means you have to, this is a pitch scale, straight line will be coincidence. Okay, so the value is the 22 number. Please you see the coincidence value 22. The straight line will be is directly connected with the 22 number. Okay, so that is the that value will be 22. So the 22 is directly multiplied with the 0.01 mm. So 0.22 mm. This is our pitch scale value. So the total reading will be, you have to add the head scale value and also pitch scale value. So with the pitch scale will be 0.22 and the head scale will be exactly the 15 mm. Exact, it's not show 15.5, 15 mm. Okay, so exactly the 15 mm. So you have to add the 15.22 mm. That will be exact diameter of the workpieces. Okay, so this is one of the simple linear measuring instruments. So linear means it has a diameter, length, and also height, thickness. For example, this is a box, means the box width, and also thickness value, width value. So the length value, square box means there is a square values. So both our values will be easily measured by the linear measuring instruments. Okay, already one saw the case studies in linear instrument analysis. This is a simple method for measuring techniques. Okay, thank you.